Why giant ship chains don't break. The process. Imagine a container ship weighing 200,000 tons. It's being battered by a violent storm in the middle of the ocean. The engines are off. The only thing stopping this billion-dollar vessel from crashing into the rocks is a single chain. If one link fails, the ship is lost. So, how do engineers build a chain strong enough to hold a floating city? It involves temperatures hot enough to melt rock, millions of pounds of pressure, and a manufacturing process that looks like it belongs in a sci-fi movie. Welcome to the world of extreme manufacturing. It starts here. These aren't just ordinary steel rods. This is special high-grade alloy steel, designed to be both incredibly hard and slightly flexible. If the steel is too brittle, it snaps under shock. If it's too soft, it stretches. The rods arrive in long bundles, some up to 6 meters long and weighing as much as a small car. Before they can be shaped, they need to be cut. Giant automated saws slice the steel into specific lengths, called slugs. But you can't bend cold steel this thick. You need heat, a lot of heat. The steel slugs enter an induction furnace. In a matter of minutes, they are heated to over 900 degrees Celsius. They emerge glowing a bright, angry orange. Now the race is on. The steel must be shaped before it cools down. Watch this. A robotic arm, or sometimes a skilled operator with giant tongs, grabs the burning metal. It feeds it into the bending machine. This is where physics gets bent. The machine grabs the straight bar and wraps it around a central mandrel. It looks effortless, like bending a piece of licorice, but the forces here are astronomical.